All right, so I'm Jim Small, and tonight we're going to kind of, I titled the talk Unicode, but it's kind of related to, so for the past couple of years, I don't know if I should say I've been getting into programming or back into programming. You know, probably like some of you, when I went to college, I had, a bunch of programming. I had Pascal in high school, and I had C and C++, and I think I might even have had COBOL in college. It was a long time ago, so I can hardly ever remember. And I used to do some scripting. I used to do a lot of Bash and even a little Perl and awk and things like that. But I kind of, for whatever reason, I got away from it. And then I don't know. It seems like in the past 2-3 years, all of a sudden, automation is in vogue again. And now everybody's talking about, scripting and automation and orchestration and DevOps and things like that. And and this is something I've been meaning to do for a long time. So I've been kind of going down the Python route. That seems to be, you can kind of debate about which language is the most popular. That's certainly one of the most popular for that area. So I've been looking into that. And since I'm a little rusty, since I got away from it for over 2 decades, and I'm kind of coming back to it, there's some things that I'm tripping up on. And one thing is that when you look at scripting languages, they are basically multi-platform. So when I use Python, and really all the scripting languages are similar, they all work across Windows, Linux, and Mac OS, or OS 10, whatever you want to call it. So, but those environments all have a lot of subtle differences. So if you run across them, you can run into some quirks. The other thing I've noticed is if you deal with most vendors, it seems to me like most programmers from the major vendors all run Mac OS. So they're kind of like, Windows, what's that? And even sometimes with Linux, you can have some weird things, because if somebody only develops on Mac OS and nothing else, it's Linux-like. It's really more closer to BSD than Linux. You can still get some quirks. So I kind of try, and I don't have access to a Mac. I usually use Windows. I also use Linux. So there's been a lot of corner cases I run into. And one of those things I keep running into is encoding. And encoding, or character encoding, of which Unicode is one example, is kind of one of those things that it seems like nobody really talks about, and at least nobody that I've ever met seems to really understand it all that well. Usually when I ask people about, encoding or Unicode, they're like, oh, that's really hard, or stay away from that, or that's a pain, or this or that. But I keep running into these weird things. And so for example, in Windows has a default encoding of UTF-16, which is a type of Unicode encoding. And I didn't even know that until I got into programming. But where you run into issues is, I'll do some Python programming in Windows, and then I try and transition to Linux, and then in Linux I'll have really weird problems because a lot of Linux stuff doesn't deal with UTF-16. It expects ASCII. And you just get really off-the-wall errors. And this is how I kind of got into this talk, because I kept running into these weird encoding issues, and I would ask people, what is going on? And nobody could help me. And I spent all this time looking into it, and I finally figured it out, and I'm just like, okay. I think like the 3rd or 4th time I ran into a coding problem, I talked to Jim, and I'm like, hey Jim, why don't I do a talk on Unicode? Because I keep running into problems and nobody seems to know about it. He's like, well, it's kind of obscure. I'm like, well, let me know. And so here I am. So there's a lot of places you can go to this. I was very surprised how complicated this gets. And I guess it kind of makes sense, as you'll see when we get into the scope. But I try to provide a broad overview to kind of hopefully give you like a high-level vantage point of the related things and how things work. Be happy to take questions as I go. There's a lot of things I was thinking about doing, but I just kind of ran out of time or didn't get to. But a lot of things from reading and doing research, if you ask me, I can tell you about. Okay, so what is Unicode? So Unicode is basically now is a way to digitally represent all the world's languages, so both living and dead. And that's a pretty ambitious undertaking. So I don't know, my wife happens to be Polish, like off the boat, right? So I learned some Polish, and Polish has a slightly different alphabet. right? And if you ever had like French or German or Spanish in high school, you've seen other Latin-based alphabets. There's also a pretty big Russian population in the area. Russians use the Cyrillic alphabet, which is totally different. There's a pretty big Arabic population. If you look at the Arabic language, completely different alphabet, right? So there, if you start looking at all the languages, especially if you get into stuff like Chinese, which is just radically different, I mean, basically no similarity to English whatsoever. And Unicode is one system, one abstraction that deals with all languages. And it's kind of cool from an intellectual point of view. If you start looking at that, that's actually quite an impressive undertaking. Because if you look at languages like Chinese, Japanese, and Korean, they don't even have an alphabet, right? They're all ideographs. So that gets really interesting, you know, how do you come up with similar abstractions? So that's what it's trying to do. And this is kind of just a sample of hello in different languages. So you have English, Arabic, I can't remember all, one of them's Chinese, one of them's Hebrew, and I think one's Japanese if I remember correctly. So you know, you can see that the scripts are quite a bit different. Even the ordering, right? If I look at Hebrew and Arabic, they're ordered from right to left instead of left to right. So there's a lot of interesting things that you have to take into account to basically support that goal. In addition, there's also a lot of things that we use all the time, a lot of symbols, icons. So things like symbols in music, symbols in science, symbols in math, right? These are things, you know, anybody who's ever dealt with complex math, you know, you can use LaTeX. You know, it's not bad, but, you know, it would be nice, right? And wouldn't it be nice if there's some system that you can use that has all mathematical, all scientific symbols, and it's just a standard, and no matter who you're corresponding with, it just works? That's what Unicode does. So even if you're dealing with really complex calculus or differential equations, all the symbols are in here. Yeah, question?
Yeah, what about in the math example you have there? Does the Unicode address the positioning of the symbols also, or just?
There is a way. So I didn't get really into this, but I did kind of briefly glance through a paper. On the Unicode website, there's a tutorial that goes through, like, if you've used LaTeX, it basically shows you how to do just insanely complex things in pure Unicode. So
math education LaTeX will do all that stuff.
it will, but the problem with LaTeX is it's application specific.
Yeah.
The advantage of Unicode is it works with any application that supports Unicode. That's the advantage.
Yeah, but I think Unicode will handle the characters for you.
But you need something like LaTeX, a layout tool to get it laid out.
Yeah, you're right. There are some formatting things. But especially like if you just want to correspond with somebody and just share equations, you're not necessarily presenting, but you just want to share data, it's nice if you have one tool that basically any application can recognize. So you're right, it doesn't deal with all the display aspects, but in terms of just being able to represent the information, it does a good job. So also for music, so anybody who's ever used Wingdings or kind of like icon type fonts, it has all those. So a lot of stuff you see on the web are just Unicode fonts. So it's pretty slick, but somewhat complex because supporting all those things is not easy. Okay, so whenever I do a talk, I always try and talk about, I try not to make it too theoretical, right? You know, so I had some problems that, you know, I'm curious to solve, but in terms of, you know, why would somebody care about Unicode? Because this is kind of obscure, right? This is not something that comes up in day-to-day conversation. So in terms of real-world use, I can definitely tell you that there's a lot of things, if you deal with any kind of development, web, email, you are going to run into this stuff a lot. You might not recognize it, but you'll run into these problems. So the biggest one is the web. So the web, let's say I'm building any kind of a web application like a blog. If I'm building a blog, right, even though I might be building it for people living in Michigan, right, I have people from Europe, I have people from Russia, I have people from the Middle East, I have people from China, from Japan, from South America. All these places have radically different languages, and all these people would like the ability to write in their own language. And if you have any doubt of that, just look on Facebook. I find it really interesting when I look at my wife's Facebook page every once in a while, because my wife speaks 4 languages. So she has friends from all over the world, and they all like, you know, they switch back and forth between their own language and English, right? And if you grow up speaking a language, it's nice if you still have the ability to use that language. Because if you learn a second language, you know, you might become fluent in it, but it's typically not the same as your first language, right? So giving people the ability to use their own native language is really a huge plus, and Unicode does that. Also, if we look at the web, basically you'll see that the vast majority of all websites use UTF-8. And UTF-8 is a form of Unicode. It's a Unicode encoding. So I'll get into the specifics of that later. So pretty much if you use the web, you're using Unicode. So, right? So especially, and where this has burned me a lot, and I'll try and cover this in some of the examples, is like how many times have you looked at something on the web and you're like, oh, that's cool, I'm just gonna copy and paste that, right? And then you paste it and you get weird characters, or you try and run something and it blows up. Well, that's because you're copying Unicode, and a lot of stuff doesn't understand Unicode, so it blows up because it's expecting ASCII. Right, so this is something that you might not have even realized, but character encoding is something that will bite you surprisingly often. Okay, and then I kind of go through some examples, right? So we talked about copy and paste. Anybody who does any kind of development or DevOps stuff. So if you deal with web APIs, this is a big one, right? So like I can speak from Python. Python 2 has some issues with dealing with Unicode. So you got to watch it with Python 2, especially on Windows. If you get Unicode characters, it just blows up. So this is, and not just Python, PHP has some significant limitations with Unicode. I think I was trying to find a general statement on this, and I couldn't quite find a definitive statement. But my impression is that languages that were developed after the Unicode Standard, so things like .NET-based languages like C# or Java, those were built from the ground up to support Unicode. Or even like Windows NT and all current versions of Windows. Those were built from the ground up to support Unicode. But if you look at Unix and Linux, that existed way before the Unicode Standard, right? So if I'm dealing with Unix and Linux and even some stuff in Mac OS, I have to be careful because some of those tools were they predate Unicode. So they're not designed to handle it. So you can run it, and we'll talk about tooling issues. And so just general good stuff to be aware of. Okay, so email is less clear-cut. So there is still, you know, I couldn't find a good statistic on this. I mean, I can tell you a lot of email is web-based email, which means it's UTF-8, right? Anything with the web is UTF-8 or Unicode. So this is certainly a large percentage of email. I can't give you an exact percentage. I couldn't find any decent source. I can tell you a lot of the major providers, Google, Yahoo, and some other ones, basically all support Unicode, but it's certainly not universal. Some people don't. Some stuff is still 7-bit only, which means it doesn't support Unicode, it just supports basic ASCII. If you look at the email protocol SMTP, that was designed long before Unicode existed. So the Unicode support is really like in MIME and kind of grafted on later, so it's a little messy. However, if you're dealing with any kind of automation or programmatic approach to email, you're almost certainly going to have to deal with Unicode. It's almost impossible to get away from. Okay, and then operating systems, so I mentioned Windows NT was built from the ground up to support Unicode. Everything in Windows is UTF-16. Mac OS is pretty good. Linux is, I said Unix and Linux, but really I mean Linux. I don't really deal with Unix much anymore. I typically just deal with Ubuntu, CentOS, and Red Hat Enterprise Linux. So those guys, a lot of stuff supports Unicode, but not everything. You really have to watch out for the command line tooling. A lot of command line tooling in Linux is unfortunately, like I said, it predates Unicode, so it's ASCII only. And you get some really interesting errors if you try and parse Unicode. Okay, and then in terms of if you if you kind of ignore it or try and get around it, you end up with stuff like this. So the most common thing is you get garbled input and output. So I'll talk about some examples at the end, but a lot of stuff that if it doesn't deal with Unicode and it tries to interpret multi-byte sequences, you'll just get gibberish or garbage, or you get like a program crash. Lots of tooling errors and failed deployments. The tooling too. This is one of the major drivers that I did this talk. Is the tooling errors are awful, right? So if you deal with Ansible or a lot of deployments, like if you're trying to deploy to Heroku, a lot of these tools, they totally cannot deal with anything but simple 7-bit ASCII. And if you do anything with a high bit set or any kind of Unicode, they just blow up and they give you totally worthless errors. I mean, it kind of send you down a rabbit hole of something totally unrelated. So you really, and there's no easy solution to this other than, I would say if you're using a Linux type tool and it doesn't work, you want to make sure that you're only using 7-bit ASCII. Corruption, the other common problem is, so again, if you're dealing with any Unicode data, which is typically UTF-8 is the most popular encoding, a lot of apps by default still assume ASCII, which is kind of ridiculous in today's day and age, but like I didn't know any better until I did the research for this. If you try and treat Unicode as ASCII, you're going to corrupt it. So you also have to watch out, and this is a lot of times this is buried like 3 or 4 or 5 levels deep in the menu in terms of your character encoding. But if you get it wrong, it's very painful. And the other thing is, if you do any kind of development, especially if you're doing anything on the web, this is something that it's definitely good to get your arms around. I mean, just learning the basics, which is probably all you have to know, is not that bad. But if you ignore this and you have to retrofit it later, it really sucks, right? And this is much broader than you think. So we'll talk about some of the details there. Okay, so just kind of a quick overview. So when I looked at this topic, that there's a lot of tangential things, and some of these things are probably more obvious if you've been a programmer for a long time, but I think a lot of you aren't, and I wouldn't consider myself an experienced programmer. So a lot of this stuff, like especially serialization, it sounds kind of abstract, but it's really pretty simple. And when I hear people talk about this, like usually people that aren't programmers, they don't understand it, or they totally have the wrong concept. And so this is really important to be clear on these two things. So spend a little bit of time on that, and then we're going to run through Unicode. All right, so bear with me because this might seem like a little bit on a tangent, but I think this is really important. So serialization, really the fundamental question is, how do applications communicate? Okay, and this kind of goes back to computer science basics. And basically, if I look at all applications run in something called a process. So a process is, in simple terms, it's like the atomic unit of execution on a computer. Now, I'm oversimplifying a little. Somebody might say, what about threads, right? So threads are kind of under the process abstraction. So I can have a multi-threaded program, but really, that's kind of low-level details that I don't care about. I'm still running a process. Right? All those threads are kind of a sub-part of the process, so I can pretty much ignore them for the sake of this talk. Now, where it gets tricky is when my application needs to communicate with another application, right? Whether it's on my computer or on another system, that other application is running in a different process. And this comes down to the fundamentals. Basically, every process on a computer in any operating system has protected memory. That means that only the process can access its own memory. Nobody else can. So that means if my process has a bunch of data, right? Let's say in my browser, I'm at a site, and I want to save that site, I want to bookmark that site, right? Or I want to instant message somebody else. Whenever I'm basically going outside the process, I have a problem. Because basically, whatever is outside of my process, like if I want to store something on disk, or put it in a database, or send it over the network, or anything else external to the process, what's outside of the process can't access the memory. It can't access the data. So I have to figure out, how do I take the data within my process and export that data. And it's not quite as simple as it sounds, because when I have data, hopefully everybody's done a little bit of programming. I might have like an array or a hash table or a string or an integer or a floating point. I have all these different types of data. And all these data are bits in memory. But the thing is, if I look, that data is represented differently even by same programs on the computer. Right? If it's a float, is it 32 bits? Is it 64 bits? Is it 128 bits? What kind of floating point is it? If it's a string, how's it terminated? If it's an array, are all of the things the same type? How long are they? How many are they? Is it nested? Right? So there's a lot of details about how the data is represented. So when I export that data, I have to do what's called serialization. I have to figure out, how do I say, here's the data, and here's how you make sense of the data. Here's how the data is represented. That's the process of serialization. And anytime I do any of those things, I have to go through this process. Okay, there's also, there's actually quite a few complications, but the only one we're going to run into for the sake of Unicode, because I'm trying not to get too far out of the weeds, there's also this thing called Endianness. So, and this is from Gulliver's Travels. So Endianness comes from processor architecture. Basically, in the x86 architecture, which is what most of us use, it's what's called a little endian architecture. And most other computers like Motorola, IBM PowerPC, SunSpark, mainframes are what's called big endian. And endian is basically, how do we represent multiple bytes, right? So if I have a 2-byte number, do I put the most significant byte, in other words, the largest byte first, or the smallest byte first? There's really no right answer. Either way is fine. But you have to decide which byte goes first. Big endian, the most significant byte goes first. And this is kind of tends to be more how we think. Little endians like backwards, where the least endian, or the least significant byte goes first. And this is the kind of stuff you run into when you're talking over the network, because different systems have different endianness. And in Gulliver's Travels, this giant goes to this island of tiny people that are under 6 inches tall, and they basically start a civil war over which side of the egg you crack. You crack the big side or the little side, and they have a civil war over it, and you kill each other, right? And it's kind of, the author was kind of joking that that's like this endianness thing, because people would argue back and forth about which one is better. So it's just something to be aware of. Now, if I want to export data from the process, I use serialization. I'm going to use some kind of a standard or a format. And this is what I think there's a lot of confusion over. So I hear a lot of people talk about like JSON or XML or YAML, and people will complain about like, you know, I don't like how it's formatted like YAML, I don't like that it's space sensitive, or XML, I don't like all the tags, or JSON, you know, whatever, I don't like the syntax. But I think what a lot of people miss is, these are not really for you, right? So JSON, XML, and YAML, these are quote unquote human readable, but they're not really designed for humans, right? Sure, I mean, you can look at a really small, simple file that's like 10 records or less, you can look at it, right? But that's not most stuff. If you look at anything in a typical enterprise, you might have thousands or tens of thousands or 1 million plus lines, right? I mean, you're not gonna look at that, there's no way, right? So really, if you wanna deal with this stuff, you really need tools. So I hear a lot of people complain about this stuff, and I think they don't understand the purpose. So this really isn't for you, this isn't for a person, this is basically how applications communicate, right? Even if I'm in an enterprise, so there's a whole, I'm not going to draw a blank, but there's a whole like department in large companies that deals with information exchange, and I can't remember the name of the group, but they basically deal with XML exchange, where basically they're going to code all their data, they're going to agree on an XML format, and that's how they exchange data back and forth. Like for example, with the manufacturer and the suppliers.
You're looking for EDI, electronic
yes,
data
thank you.
interchange.
That's right, exactly, EDI, right? So these things, again, right, I have two groups, each group has applications, those applications on different systems need to communicate, that requires serialization. So I have to use some kind of agreed standard. That's what this is for, right? Binary, BSON is binary JSON. right? So if all this stuff is gibberish, JSON comes from JavaScript object notation, but really it's used by everybody. So this is really popular, especially for RESTful web interfaces, because it's really easy to do and pretty much all languages support it. XML is used by everything. YAML is kind of a popular configuration management format. Binary, like ASN.1, this is used by SNMP. BSON, this is used by MongoDB. It's a binary JSON. Binary, the advantage is it's just more efficient. So if I'm dealing with lots of data, or I'm dealing with embedded devices where efficiency is critical, then I'm going to use a binary encoding. And then IDLs, this is like interface descriptor or definition language. This is basically, if I'm writing a complex program, maybe a complex distributed client-server application, and I have serializing my data can actually be in a programming language, can actually be pretty complex. So if I'm writing a complex client-server app that's distributed, and I need a way to deal with any language. So let's say maybe I'm writing Python because I'm not like a professional developer, but let's say, you know, at the head end they're using C++ or Java or C# or something like that, right? So it gets kind of tricky. If I have to support different languages or different systems, how do I do that? These are almost like a framework. So I can run these, they kind of support pretty much any language, and this gives me a way to come up with a serialization library or routine for the language so I can communicate. And a lot of people that don't know any better will try and do this on their own, and they'll inevitably have very buggy code that's impossible to debug, right? I mean, this is kind of like trying to write your own socket code or doing really low-level stuff. You don't want to do it, right? This is really, really hard to get right. There's a lot of wicked corner cases. So for anything like this, you do not want to roll your own. You basically use one of the standards. And there's a lot more. These are just some of the more popular ones. Okay, and then we have character encoding. Okay, so don't want to give you too many details, so I try to just pick the most relevant things. But I think this is important at a high level just to understand the background. So character encoding is basically how do we digitally represent discrete characters, right? So an alphabet or a bunch of symbols or however the language works, how do we represent that digitally? That's my encoding. And then a character, I had to look this up, I didn't really know this word. A character is essentially a grapheme. So a grapheme is essentially an atomic unit or the smallest semantically meaningful unit of text. And again, remember, Unicode has to support all languages. So this is actually a pretty tricky abstraction because there's a lot of things that, like, you know, when I kind of started looking into this, there's a lot of things that I thought were just, you know, this is just the way it is, but actually everything I thought I realized is only the way it is for Latin-based alphabets. If I look at different families of languages like Indic or Arabic or Hebrew or Chinese, it's totally different. It's a totally different system. The way things are combined, the way you make letters, totally different than with an alphabetic system. So this is essentially dealing with the smallest possible units. A coded character set is basically all the characters I care about. So like, let's say the Latin alphabet or the alphabet for English, I'm going to take that and I'm going to assign each one of those characters a unique name and a unique number. So that's the coding. The code point, this is the number. So I think like 65 is 8, right, in ASCII. That's the code point. The code point is the number I assign to the particular character. The code unit, this is when I'm basically representing the character, when I'm encoding it, what's the fundamental unit? Is it 7 bits, 8 bits, 16 bits, 32 bits? You get that's how it's going to work. And this will kind of become clear when I give examples later. Now, these guys are legacy. And this is another thing too. How many people have run across character maps, char maps, code pages, right? If you start getting into like any system, Windows, Linux, Mac OS, you'll start running into this. And I think they still use them internally, but this is legacy stuff, right? This is basically pre-Unicode. And I'll give you some examples, but if you ever dealt with ancient systems where you could only access 1 meg of memory, and above 1 meg you had to use that that EMMM page to swap stuff in and out. This is like the same thing for characters. And then the encoding scheme, this is basically the serialization scheme, right? So if I have Unicode or some other system, that's how I represent things, but when I actually put it on the wire or between applications, this is my encoding. Okay, so just quick bit of history. I'm not going to go through all of them. I try to just pick the ones that I think you've heard of. So if you ever did anything with engineering and computer science, you probably heard of BCD. That was one of the first codings. And then I didn't realize this, but that's actually where EBSDIC came from. So EBSDIC, everything, I've never dealt with it personally. I think it still exists in really old mainframes. It's kind of a good luck if you have to deal with it.
Yes, 400 essentially.
They put a man on the moon.
All right. So,
We did.
How long ago?
Today if you try, you never get it off the ground
Yeah,
yet.
and what have we done since?
Yeah.
Whole different.
We won't go there.
so, so when IBM, I've heard a lot of non-positive comments about EBSDIC and IBM, but actually IBM I didn't realize this, IBM was a big pusher for ASCII. Even when IBM had EBSDIC, they basically said themselves like this is not the way to go, we have got to push a standard. So as much as people give IBM flack, they were actually a big proponent and driver of ASCII. So ASCII was really the first, at least for the US, this was the first major standard character encoding, or people from different systems could agree on how you encode the character. Because before you have a standard, if you have to communicate across a network, I don't know how you do it, because it's totally proprietary. And then I'm sure a lot of you have seen this. I kind of just showed part of it, but this is your ASCII table. So one other thing too that's worth mentioning is true ASCII, the actual ANSI standard is only 7-bit, which means it's only characters of the first 128 characters. So all the extended characters with the accents and all that stuff, that is not ASCII, and that is not standardized. So, and then that causes a lot of interesting problems. I just wanted to point that out.
If you ever need that table quickly, man space ASCII.
Okay, yeah.
If you have your manual pages and stuff, man space
All right.
ASCII is your friend.
Now, ASCII came out. So basically, what started happening? I didn't know which order to show this in, but what started happening is, computers are becoming, so this is back in the 60s and 70s. Computers are becoming more and more popular. Now you have the internet. You have a lot of people collaborating, especially in universities and government. And so basically, you have all these different areas of the world that each have their own language, right? So we came up with this idea of code pages. And different vendors call them different things. In Linux and Unix, it's usually called char map or character map. In other systems, it's called a code page. I mean, it's basically the same thing. And this is basically saying that most people took ASCII and then they used the top 128 characters. They added an 8th bit, another 128 characters, and then they'd add their whatever they needed, right? So for other Latin-based languages, like French or Spanish or German, it was pretty easy because the differences weren't that big. For some of these like Cyrillic and Greek or Hebrew, it's a totally different alphabet, but it was good enough just with another 128 characters. And so what you ended up doing is you had all these different code pages. Now this was kind of a nightmare because if I'm sending data to somebody else, I have to basically figure out how do we agree on a code page? Because there's no in-band way to say this data is this code page. There's no way to indicate that. So this was a mess. So it made communication really hard. And on top of it, this is just for Windows. Every vendor, every major vendor, so IBM, Apple, Adobe, Xerox, everybody had their own set of code pages. And not only did they have their own set of code pages, those code pages were per product. So Windows had one set of code pages, DOS had another, IBM's PC-DOS had one, VMS had another, AX had another, Solaris had another, Macintosh had another. Everybody did their own thing. No standards. It was a total nightmare.
There was a standard. It was called the Tower of Babel.
I missed that one in my research. So the ISO tried to somewhat help, and you might have heard of this ISO 8859 or ISO 8859-1. So this is basically standardizing primarily Latin-based alphabets, although there's a few exceptions, right? You have Cyrillic, Arabic, Greek, Hebrew. But this standard is dealing pretty much with people that use an alphabet. So, you know, that's okay for like the US and Europe, but for large parts of the world, that doesn't work. So if you didn't have an alphabet like Indic or Chinese, Japanese, or Korean, or some of the other languages, this didn't work. So I don't know what they did at the time. So this was a start, but it still left a lot of gaps. So actually, even Unicode, even the web didn't really get going until the early 90s, and Unicode really predates that. So even before the web took off, this was already a major problem. I mean, with the web, it was just totally untenable. So you have all these different languages, and this is called a pangram. If anybody ever took typing, probably dating myself admitting I took typing, but if anybody ever took typing, you might have typed this: the quick brown fox jumps over the lazy dog. Does anybody know what's the significance of that? Anybody remember?
Uses every letter.
That's right, uses every letter. So if you look at kind of equivalent stuff in other languages, so the Latin-based languages, German, Polish, Greek, actually not Greek, but these three, Spanish, you know, they're pretty close. You know, you can kind of make them out. Greek, Cyrillic, totally different. Hebrew, Arabic, Japanese. So, because before Unicode, there was a way to kind of switch back and forth between code pages, but again, this is a nightmare because there's no in-band way to do it. So when I'm writing a program or developing something, I basically have to figure out some clever proprietary way to basically say, okay, this group of text is this encoding, and this group of text is this encoding, and this group of text is this encoding, and if I want to share that outside of my system, like, good luck. So this is kind of the mess we had before Unicode. All right, so again, the idea with Unicode is, you know, all these code pages and character maps are a mess. It doesn't work. For domain-specific things like math, science, music, icons, you know, we need a way to have a standard that everybody can share. And this, I thought this was kind of cool from the Unicode site. So you can actually see, this shows the major languages. So you have languages that are alphabetic, languages that are logographic. So logographic are, that's like Chinese, Japanese, and Korean. Those are languages that they look like symbols, and they call them ideographs. They're actually not symbols. I found that out when I was looking, but they're kind of like that. These are totally different. You have Abjad, which is Arabic and Hebrew, and then you have the Indic languages. So those are, you know, there's other ones. Those are the major groups. But it's kind of interesting because if you look at these families, they all approach things totally different. So all the fundamental rules, how I group things, how I pronounce things, how I write things, they're all different. So it's a pretty ambitious undertaking to support all of them. All right, so like any standard, when Unicode started, you know, you can't have something that's too ideal. You know, if it's too ideal pie in the sky, then people aren't going to sign up, so you have to make some compromises. So when this started, it was essentially a group of the major vendors. I think first it was Apple and Xerox, and then IBM and Microsoft, and a few others got involved. And pretty much all the major computer vendors got involved with this Unicode standard. And when they came up with it, they're like, you know what, 65,000 code points, that should be more than enough. You know, because we've been dealing with, you know, code pages that are 256 characters, so if we go up to 65,000, that should be plenty. Now, this was primarily maybe European, but not, I don't think they really involved anybody from the Asian countries. Because the problem with this is when ISO looked at it, I think ISO is more inclusive. They kind of went to the other extreme. They said, okay, we're going to do, and I don't know why they did 31 bits instead of 32. I couldn't find a good explanation of that. But ISO said, we're going to use 2 to the 31 bits, which is 2.1 billion possibilities. So we can get anything. And that's what they went for. And then the vendors looked at that and they said, you have to keep in mind, this is back in the day when, people would optimize down to the bit level because memory was so scarce, right? This is like a different era. So, and I remember dealing with this, I remember when you had less than a meg of memory and you were optimizing every byte. So this was in that era. And so the vendors looked at this proposal and they said, you guys are crazy. And the vendors basically lobbied really hard and got a bunch of major countries to veto it. And they said, there's no way we're doing this. So the two groups worked and they came up with a compromise. And the compromise is basically, we're going to use 2 to the 21 bits, which is about 1.1 million. So originally the vendors just thought of living or actively in use languages. But with the revised one, everybody kind of agreed, it would be nice if we could do any language. Even dead languages or old languages or experimental languages or things like mathematics, music, symbols, things like that. And with this compromise, everybody thought that this was more than enough. And the reason I give these numbers is when you kind of look at how Unicode is built and you'll look at some of the stuff, you'll be like, why did they do it that way? This is why, if you look back at this history. Okay, so quick terminology. So Unicode is basically a character encoding. So it's like I talked about before. So I'm not going to repeat that. Now, I did run across, there's different terminology. You'll hear about Unicode and the Unicode Consortium, and you'll hear about the Universal Character Set and ISO 10646. And a lot of people will equate these, but they're actually not the same thing. So UCS was basically what came from ISO. So Unicode is what came from that original group of vendors. UCS is what came from ISO. So the two are harmonized so that basically they match. But they're not the same thing. Unicode is essentially a superset of UCS. So really you want to use Unicode. And UCS is really, I don't know, I mean it's kind of, I guess a minimum, but it's really not enough. This is the one you want to stick with. And then the ISO 10646, that's basically the standard, and I'm not going to read this whole thing, but there's a working group in ISO, and they basically harmonize with Unicode, and they deal with all the worldwide politics, deciding if new languages should be included, things like that. And that group, this is the standard they publish. And that standard gets updated every couple of years. So if you actually go and look on Wikipedia, the latest version of Unicode is version 10. And I think there's something from the ISO that came out either this year or last year, and like every couple of years they'll come out with a new amendment. And then this also threw me too, because I hear about Unicode and I usually hear about UTF-8. So UTF, this is basically how I serialize Unicode. So this is my encoding format. And there's a bunch of different schemes of which UTF-8 is the most popular. So just to be clear on that, right? So Unicode is basically how do I represent the character set? What's the unique number I give the character? What's the unique name I give the character? What's the character? How do I display it? Things like that. That's what Unicode is. How do I actually encode it? How do I save it to disk? How do I send it across the network? How do I communicate? That's what UTF is for, right? So I hope that's clear in terms of the difference. Okay, so these are just some charts. We'll come back to this, but so when Unicode was actually, I think it was first standardized in like 91 or the early 90s, and so you can kind of see this goes back to 2000. So when UTF-8 came out, it didn't take off, right? It took a while, like 10 years, but you can see that as the web and everything started taking off, UTF-8 really took off. And I showed earlier, right, about approximately 90% of all websites are UTF-8. So this is really, you can see all the other encodings, ASCII only and some of the other code page type setups. Those are really fading away in their tiny percentages, and UTF-8 is where everybody's going. Okay, so mechanics. So this is something that also wasn't clear to me. When I would see Unicode numbers, I'd see all these different variations. So this is how it works. So there's 2 to the 21 code points, or basically 1.1 million possible values. And they're formatted like this. So the most common value you're going to see is this U plus and then 4 hex digits. right? With hexadecimal being 0 to F. So for example, this is the Latin A. Now, one thing they did that makes it kind of easy for us is the ISO 8859 or Latin 1 standard, which was the most popular extended ASCII. That's basically the first 256 characters of Unicode. So from our point, if your first language is American English, it's pretty convenient for us because that's how they did the first one. And then everything else is kind of logically added. Now, there's also these optional first 2 digits. And I would see sometimes, most of the time I'd see this, but every once in a while I'd see 1 or 2 digits before. And I never really understood, what are those extra digits? So Unicode also has this idea of planes. And planes go back to the history. So remember, when Unicode first came out, they only had 16 bits for it, or 65,000 characters. And then ISO wanted, 2.1 billion, and they compromised in the middle. But when they compromised, the original Unicode standard was a 16-bit standard. And so they had to figure out, okay, how do we retrofit this 16-bit standard so instead of just accessing 65,000 characters, it can access 1.1 million. And the way they did that was with planes. So there's essentially 17 planes, and each plane has 65,000 characters. So, and we'll kind of talk about the encodings and the pros and cons of each one. But that's these leading digits. So if I just have 4 digits, if there's no leading digit, then it's basically plane 0, or the basic multilingual plane. And this is probably 90% of what you run across, 90 to 95%. However, especially if you get into a lot of the symbols, or if you deal with any of the East Asian scripts, then you're going to run into this. You're going to run into the higher code pages. Okay, so this is more of a reference, but I would run into this. I'd run into this stuff, like especially the BMP. I would hear the BMP. I'm like, what is a BMP? So basically, if you look at these 17 planes in Unicode, they have names. So the basic multilingual plane is the default plane or plane 0, and this is basically what most, 90 to 95% of what you use. And I believe, for example, in Python, I think Python can I don't think it can access stuff outside of that. So there are some stuff that hasn't been updated and doesn't deal with everything. You also have a few other planes. So plane 1, this is actually useful. I kind of spent some time looking around on this, and I put a lot of links at the end if you're curious. But especially like if you get into math or symbols or emoji, and you may not laugh at emoji, but like if you're a website designer, I mean, that's a big deal. So all that stuff is in here. So if you deal with a lot of web stuff, you'll probably have to touch this guy too. Plane number 2 is just if you deal with basically East Asian scripts. So if you deal with Chinese, Japanese, or Korean, you might have to deal with this guy. This is non-graphical characters, so I don't think you'd ever have to deal with this. And basically the last 2 are for internal stuff. So basically for fonts and rastering systems, stuff like that, they use this internally. And then one other thing too, I just showed just so you have an idea. I think there's roughly like almost 140,000 assigned characters, just to give you an idea of the magnitude if you look at everything. So allocated is basically what's reserved, and assigned is what's in use. So if you add all those together, that's actually what we're using today in terms of how many characters. So roughly speaking, about 75% of the space is still available. So the 1.1 million looks like it was a good compromise. That seems like it should be more than enough, basically to cover all the world's languages and symbols. Okay, so this is just kind of I tried to give a basic example like I showed the ASCII chart. So this is just showing, I didn't want to get too much into detail, but if you take various characters, so each character has a code point, and then each character has a unique code point, a unique description or name, and then you have the encoding. So the encoding is basically how do I represent it? So UTF-8 is kind of a clever multi-byte encoding. So we'll come back to that, but it can be 1 to 4 bytes. That's what most things use. UCS2 was the original Unicode standard. That's only 16-bit. So UCS2 is actually deprecated because it can only deal with the first 65,000 characters. But I throw it in there because there is a significant number of things that still only support UCS2. UTF-16 was basically its replacement. So this is a 16-bit encoding. So if I look, you can see that all of these, in this case I have twice as much. So you'll kind of run into a debate about should I use UTF-8 or UTF-16? So here, you're pretty much always going to use UTF-8. That's the way to go. But if you're like, for example, if you're Chinese or you're dealing with applications in China or Japan or Korea, then you might prefer UTF-16 because you can see, like, once you get into these higher level characters, it's not so efficient in UTF-8. Right? UTF-8 is great for the Latin-based alphabets and the other alphabetical systems, but if you get into the logographic or the symbolic scripts, then it's not so great. It starts being 3 or 4 bytes, so it's better to just use UTF-16, which is almost always just going to be 2 bytes. There's also UCS4 and UTF-32. Now, unlike this is a little confusing too. UCS2 and UTF-16 are different. UCS2 is the original. It can only deal with 65,000 characters. UTF-16 is a replacement and enhancement that can deal with any Unicode character. However, with UCS4 and UTF-32, they're identical. There's no difference. Now, if you look at the encoding and you look at all this wasted space, you kind of might look at that and say, why would I use UTF-32? I mean, it doesn't make any sense. And basically, the reason you have UCS4 and UTF-32, it goes back to the original UCS proposal. So the original UCS proposal, or Universal Coded Character Set, was 31 bits, right? So if you have a 31-bit character encoding, then UCS4 or UTF-32 make perfect sense, except you don't. So basically,
UTF-31.
Yeah,
Technically, yes.
that's because that's a good question or a good point. So it's because the actual encoding is 4 bytes. But yeah, that is kind of weird. So I don't know if they were going to use it as a parity bit or why they did that. Now, there is the one advantage of UTF-32 is if you look at these high code pages. So if we're dealing with a Unicode character above code page 0, like for example, this is code page 2. Then this is a little easier. Because the way I encode it, even with UTF-16, I still have to use two code pairs, not just one. And I have to do something called surrogate pairs, which makes it a little tricky to process. So if you deal all with East Asian scripts, UTF-32 is kind of nice in that it's always consistent, it's always the same length. And from what I read in Linux, a lot of Linux systems like using UTF-32 internally because then they'll basically use those extra 11 bits for internal housekeeping. So some stuff does actually use it, but typically just internally. Like in terms of programmatically, as far as I know, nobody uses that. Or rarely. Okay, so typical problems. So if you're dealing, it's gotten tremendously better just in the last year or two. What's changed is, I'm sure, well, if anybody ever had to deal with foreign sites before, like if you went to non-English sites, a lot of times you get like these questions or these weird things because you didn't have a font for it. That's changed because now if you look at website design, everything is just downloaded. So it doesn't matter if you don't have the fonts, your browser will just automatically download them. So a lot of times when you're looking at a foreign page, like a non-English page, you'll have to wait like 3-4 seconds, but then it will download a font and then everything renders correctly. So a lot of this isn't true for browsers, but for terminal apps, for email and other things, you'll run into this where you might not have the correct font. So the Unicode Standard actually has a replacement character. So if your application understands Unicode but doesn't know how to render the particular Unicode character, that's actually what it's supposed to display. So if you see a bunch of questions like this, then basically your font or your system is having trouble dealing with a particular Unicode code point. A lot of times too, you'll get stuff like this, gray or black box or some kind of a blank box. That typically means that you don't have the right font or you can't support that Unicode character. The other common thing is, again, if I look at terminal apps, it's not just Linux. Like for example, the Windows console app, I think it's fixed in the latest version of Windows 10, but in Windows 7 there are a lot of limitations. So if I try and display Unicode in my Windows console, it's going to interpret it as ASCII. Same thing in my Linux console. It's going to interpret the stuff as ASCII, and I get stuff like this. Because it's essentially getting a multi-byte sequence. And this first byte, is a high byte range it doesn't recognize, and then the second one it's treating as an extended ASCII character. But those are all actually one character, so it's not rendering them correctly. So whenever you get these boxes, that's a sign that your app doesn't like Unicode. Okay, so there's also, so I've used Linux. I mean, my first operating system was Sonos 3. So I've used Unix and then Linux for a long, long time. And one thing that I'd run into is I would notice, especially when I was coming remotely from a non-Unix system, or so like if I went from HPUX to Solaris, or AAX to HPUX, or AAX to IRIX or something like that, if I went between systems, or I went from Windows to Unix or VMS or some different system, a lot of times I get these weird terminal problems. And I never completely understood this. And finally, when I went through this, now I understand what's going on. So this is an example. On Ubuntu 16 LTS, on a typical terminal program in Windows, Secure CRT is one of the best. Awesome program. But if I just type man, this is what I'll get by default. And this is a very common problem I run into all the time. So you can see, obviously, that's not right. Something's wrong. And I never understood, like, what is the deal? Like, my terminal type is set correctly, my terminal emulation is supported, why does this not work? So this isn't a terminal emulation problem, this is a locale problem. So if I look at the locale, in most modern Linux systems, your locale is going to end in UTF-8. UTF-8 essentially means that Linux is encoding the characters in Unicode using the UTF-8 encoding. But the problem is, your terminal program is not expecting UTF-8. It's probably expecting extended ASCII or something else. And so this is the result, right? Simple ASCII characters appear. Anything that's not simple ASCII is garbled or garbage. So the solution was, and this is kind of something I stumbled across before, but I never understood it till now. The solution is basically in the program, and you can see you have to go way deep in terms of menus, is you have to find your character encoding, and it's typically set at default, which is supposed to be smart, except it usually doesn't work. And you have to change your character encoding from default to UTF-8. And Secure CRT is an awesome program. I don't know if anybody ever used it. I mean, it's fabulous. So I'm not trying to pick on them, but it's a really common terminal problem. Yeah.
One of the issues too is that Windows, in their infinite wisdom, decided to do something completely different from everyone else and use UTF-16 as a default character set. So all the Unix-based OSs will use UTF-8 because you can map the entire ASCII set in that first page. And Windows, because they have to be different, had to do everything in UTF-16 because they figured that was the better way to do it. So that's part of it right there.
There's pros and cons of each approach, but I think Microsoft was one of the original members of the Unicode consortium, and I think where they were going is, their thought was, if we use UTF-16, then we're going to support everybody globally. Right? Including China, which was a really important target for them. Whereas UTF-8 actually is not so good in Chinese. So part of it depends on where you're targeting, right?
Exactly.
Or even like in India, it's the same thing. UTF-8 is not so great. Like I've heard a lot of criticism from India. UTF-8 is, so it's kind of relative, right?
Yeah.
If you use an alphabetic script, then it's great. If you don't, then it sucks. So. Okay, so this is one thing that now I finally understand, is this is an encoding problem. Okay, so there's a lot of stuff I've run across. So as I've been getting into automation and development and stuff, Git, Ansible, Heroku buildpacks, a lot of these tools are basically ASCII only. And when I say ASCII, I mean like only the first 128 characters, not extended ASCII, not ISO 8859-1, not Latin 1, just simple ASCII. If you give them anything else, either they do weird things, or they treat it as a binary file, or they just blow up. And the errors are totally unhelpful, right? So Git will basically treat it like a binary file, like it's an image or something, which is kind of worthless. I mean, if you're trying to use it as a version control system, treating it as a binary file is worthless. So this is kind of problematic. There might be a better way to deal with it, but not that I've discovered yet. Ansible and Heroku, so these are things that I use semi-often, they basically just totally fail. And the error is totally not obvious. Especially for this one, I mean, I probably spent a week trying to figure out why, and nobody could help me. That was the big driver for this talk. Nobody could tell me like why this works on my system. But this is why, is if you have Unicode, it fails. So I finally figured out that basically all the files I have to convert into simple ASCII, and then it worked. And I still am surprised because in the class I'm taking, there's people from all over the world, but I don't know, for some reason I was the only person that ran into that. So this is something that I figured out, especially for Ansible, because I use that on a fairly regular basis, is if you're using Vim or you can use regular expressions, just about everything supports regular expressions. Basically, if you search for anything that's higher, that has a higher code point than 7F, that's basically not ASCII. Extended ASCII doesn't count. So like in Vim, you can do this. And this is one of those errors I talked about in the beginning, where a lot of times I'll have some kind of an online course, or I'll see something like in, I'm drawing a blank, but the developer help place that everybody uses to Stack Overflow, thank you. Yeah, so Stack Overflow is awesome, right? So you see somebody shows exactly how to do it in Stack Overflow, the code's beautiful, you copy and paste, it blows up because there's like some non-visible character that is extended ASCII. And, or there's a Unicode sequence, and then all of a sudden, because most scripting languages by default, they assume it's ASCII only. Now you can tell them, don't treat my code as ASCII, treat it as, as Windows 1252, or treat it as Latin 1, or treat it as UTF-8 or UTF-16. But if you don't explicitly tell it that, by default, I think Java and .NET are exceptions, but I think pretty much, maybe PowerShell, but I think pretty much all the scripting languages, if you don't tell them, they assume you're just giving them ASCII. And they'll blow up. So Ruby, Perl, PHP, they all do. Python, they don't like it if you give them non-ASCII. So this is a good thing to know if you're ever doing any scripting and you copy and paste from the web. Okay, and then, so I talked about this briefly, about UCS2, so I just wanted to quickly mention this because I've heard this come up a couple times too, so I thought it was worth mentioning, and that's this idea of surrogate pairs. So originally, again, Unicode or UCS2 could only deal with 65,000 characters. So to deal with all 17 areas, they came up with this idea called a surrogate pair. And a surrogate pair, you're going to see if, so I have an example right here. The first range, or the high surrogate, is going to be like in this range, and the second one's going to be in this range. And this is kind of a way you extend the 2-byte encoding to 4 bytes, and then by extending it to 4 bytes, then you can basically represent all 17 areas of Unicode. So there's actually like a whole formula in terms of how you build it, but I thought that was getting too much into the weeds. I didn't put that in. I have a link at the end if you're curious. But just if you run into these D8 to DF values, that's one of those surrogate code pairs, because you'll see people mention this from time to time. Okay, and then a few other things. So Craig already mentioned this with UTF-8. So UTF-8 is a pretty slick encoding. It's a variable length. And what's slick about it is, for true ASCII, the first 128 bytes or characters, UTF-8 and ASCII are equivalent. There's no difference. So this is good and bad. It's good because if you just have simple ASCII, you also have UTF-8, which is kind of cool. However, the bad thing is, sometimes you might, again, like when you copy and paste from a web page, 99% of what you have is simple ASCII. But there's some hidden, non-low byte character that basically is going to blow up your program. So and that's because anything past 128 bytes is a multi-byte encoding. And you might only have like 1 or 2 of these multi-byte encodings, and that'll get you. So this is one thing to watch out for. If 95% of it looks right, but you're still getting weird errors, you're probably dealing with UTF-8. And let me just flip back to this real quick. Okay, so now that we kind of briefly talked about these encodings, you can kind of see with UTF-8, right? ASCII, totally, it's just the same as ASCII, it's simple. Then like the Latin-based alphabets or the simple alphabetics, Again, pretty easy, multi-byte, pretty straightforward. Once you start getting into the logographic and ideographic glyphs or symbols, you know, then it starts getting pretty big. But it is generally UTF-8 is the way to go, you know, from a US point of view. One other thing I wanted to briefly mention is you're going to see this BELE. So remember before we talked about Endianness, big Endian and little Endian. So you will actually see some architectures will explicitly say we're using UTF-16LE or UTF-16BE. So when they say that, they're basically talking about the byte order. And on this one example, this is, right, and this matches the Unicode code point, so I think big Endian is kind of like intuitive. And this one that looks backwards, that's little Endian. So x86, which is what most of us use, uses little Endian encoding. So just keep that in mind, that if you're actually looking at raw data, like if you're doing a dump or using a hex editor or something like that, you're probably, on the x86 it's going to look like this. So it might look backwards, that's why. So I threw in that one example. Okay, and then the last page. The only other thing I wanted to mention is file encoding. So this is something that I never really paid attention to before, but actually a lot of programs will actually specify, do you want to save it as ASCII, is ANSI? ANSI is not a standard, it's one of Microsoft's extended ASCII versions, but it's pretty popular. Do you want to save it as, sometimes like Microsoft will say Unicode. Unicode from Microsoft or Windows means UTF-16. Endian, or UTF-16, actually I forget the Endianness, but that's what they mean. And you'll see it in Linux, where it will say like UTF-8, UTF-16, ASCII. So when you see those file encodings, it's actually worth taking a minute to think about that. You know, am I sure that it's really ASCII or that it's really Unicode? Because if you basically save it as the wrong type, you're gonna cause data corruption or data loss. And the other thing too is, there's no great in-band signaling method. So there are some things like in UTF-16, you have a byte order mark, which is FFFE or FEFF, which that's how you can tell if it's big Endian or little Endian. So you can look for something like that at the beginning of the file, and there's a similar sequence in UTF-8. I didn't actually put it on my slides, and that's how Windows will actually put that 3-byte sequence in UTF-8 file, so it knows it's UTF-8. Not everything likes that though. So there's really, again, unfortunately, there's no standard way to indicate this is my character encoding. So that kind of sucks. So your best bet is probably, you know, just use simple ASCII, and for everything else use probably UTF-8 or UTF-16.
Jim, so that Unix is magic character sequence that kind of tells you the kind of file you're dealing with?
Yeah, unfortunately it doesn't work. Because the problem is, like, going back to, like Craig said, right? Linux is typically going to use, or often going to use UTF-8. Well, the problem is, what if the only multi-byte character is like 95% through the file? There's no standard or agreed upon method to say this is this kind of file. I think there were some ideas, but I don't remember if they didn't catch on or. Anyway, that's the state. So unfortunately, it's not automatic, and so hopefully, going through this, it helps you, and next time you'll know what to do. So with that, any questions?
So if you get a file, hitchhiking on the comments you and I just shared, you get a file from somebody and it's got some kind of encoding in it, you're going to have a tough time if they don't tell you what it is.
So there are, and this is something I kind of ran out of time, but there are some pretty good tools. So before I did this talk, I had no idea how Unicode worked. And I can't remember the name of it, but Mozilla has a pretty sweet tool that's cross-platform, and it, like 99% of the time, it will detect the file encoding. So I can't remember, but if you search for like Mozilla file encoding discovery, it'll come right up, and then you can use that tool. That's what I used at first, and then it would tell me like UTF-16 or UTF-8 or ASCII or whatever. And also built into Linux, there's a utility called iconv, I-C-O-N-V, and that can convert between character encodings. So you can convert between any two character encodings using that. Although make sure you know the original one, or you're going to mangle it.
If you do any API stuff, the API really should be documented to say whether it's what it is. And if you're doing any web services, you're going to get an HTTP with characters set. value on it that tells you, I think it's the is it the
Content type or
content type
something
will
like
have
that.
a semicolon char set,
Yeah.
UTF-8, to tell you that the
That's
data
good.
that's coming is UTF-8.
That's good, but believe it or not, and that's the way it should be,
Yeah.
but I can tell you from my experience doing some web scraping, there are still some sites that don't have that,
Yeah.
or it's wrong.
Right.
So sometimes you still have to, unfortunately,
Strive.
it should be there. The standards require it.
Yeah.
It should be there.
Yeah,
Sometimes you're stuck though, you have to guess or use a tool,
yeah.
unfortunately.
One of the fun ways to become an accidental expert at this is to do CSV files. And that's because Windows has its own interesting ideas of how to do a CSV file.
There's no standard.
There's zero standards
Yep.
for it. So you basically,
that.
one of the tricks that we did was, looking at the first 120 characters to see if there was anything that was obvious. But of course, you mentioned 95%.
Yep.
You end up with a vendor or a model name with a trademark symbol in it.
Yeah,
And
exactly.
that's the one UTF
Yeah.
character you
Mhm.
have in the file, or
Yeah.
the wide character, the double wide character. Yeah, that's what's bitten me more than once.
So there's a whole other thing I didn't get into. Probably everybody has if you get into programming, everybody has their favorite language, and this is totally language specific. But like I can tell you from the Python point of view, Python 2 and 3 are totally different. So in Python 2, like Unicode was an afterthought. It's not a first-class citizen, really. Python 3, there is only Unicode. So if you do network programming, that's a huge change. And I think Tickle, I don't know if they ever really did it right. Perl kind of has a dual personality with that. PHP has a dual personality. So a lot of the scripting languages, you really have to be careful, what type is it? Because you might get back Unicode from the web, but then if you store it in a regular string that's just ASCII, well, it depends on the language what's going to happen. It might blow up. It might just silently work. So you definitely got to be. You're right. It should always be documented in the library, but it's definitely something you got to watch for. Any other questions?
Time to give away some books.
All right. So just real quick, I'm not going to spend any time on this, but I tried to put everything I use as a reference up there. So if you're actually curious about any of the areas, actually Wikipedia was fantastic. And then Unicode has a lot of papers on if you're curious about the math or the music or the discipline-specific stuff, they have some really good information. So I'll send this probably to you, Craig, and then
Sure, I'll get that up.
it'll be up on the website.
Jim, you were mentioning that just a few months ago, they updated that ISO 1006446 standard.
Mhm.
They did that back in June, and they added a few emojis and some characters or ideographs from Zanzibar, like a country in Africa or something. So
Yeah, so
that's
they
why they
keep-
updated it.
yeah, they
Just
keep
a tiny,
updating.
tiny increment.
But it is if you look through some of the stuff, there's some pretty cool stuff in there, especially with the icons. So it's definitely. I had one. Where was it? Oh, this one. This Unicode character table. So I'm taking some MOOC classes through a provider called Udacity, and they pointed me to this Unicode character table. So this is pretty cool. If you go here, it basically has everything organized. So you can view it by language, by symbol, by emojis. You can even say show me this specific plane. Any way you can slice and dice Unicode, this can show you, and it's pretty sweet. Because especially if you're I'm doing some web design, if you're doing any web design, it's really cool if you use the built-in icons because they're just there. Whereas if you use a special font like Wingdings or something like that, those are all proprietary. So then is it going to work on other platforms? How do I get it? So Unicode is actually pretty cool because you can consistently count on it. All right, and with that, I will wrap.
All right, it's time for our first giveaway.